Welcome to the second half, or the second part of the cadastral mapping classes. This is chapter 3. We're going to talk a little bit about the basics and the history of drafting and talk a little bit about the tools and things like that. There's something very important that I want to talk to you about first, and that is the homework for chapter 3. I know it's very unusual to talk about the homework before the class, but if you haven't looked at the homework for chapter 3, I need you to look at the homework. Really, the homework for chapter 3 is to get the supplies you need. Because we're talking about tools, I want to make sure that you have the tools you need for the later chapters that we talk about in drafting. So look at that. Fast forward to the end of this, or after you've watched this, and I explain what the tools are. I'll be specific in what tools you'll need, but the homework has a list of tools you'll need and some suggestions. So if you don't have those tools, you need to get them, and we're getting them here in chapter 3 so that you'll have plenty of time to get them. Most of the tools that we talk about for the homework are available on Amazon, or you may already have them. If you already have them, great, then you're done with the homework. If you don't, you need to get a hold of them. They're pretty cheap. There's different kinds. Some of them are available just at your local store. Others are available, like I said, on the internet or through Amazon. You can buy almost anything on Amazon. So, like I said, we're going to talk a little bit about the history and the basics of drafting. So, some of the definitions. So drafting, when we're talking about cadastral mapping, we talk about drafting. That's the art of representing records on a plane surface such as paper, linen, mylar, or other instruments. Part of those drafting is how lines and their relationships to each other. So you'll need to know and understand the relationships between these lines. We're going to go over five of these relationships here. You need to know those. The first one is parallel lines. Parallel lines are lines that are the same distance apart throughout their entire length. There's an example there in your book. An interesting note about parallel lines, these ones here are shown at a certain angle, but they could be at any angle as long as they are the same distance. They can be at a 45-degree angle, 90-degree angle. It really doesn't matter as long as they are at that same angle or same bearing, then they are parallel. Intersecting lines. Intersecting lines are any that cross each other at some point along their length, and the point at which they cross is called the point of intersection. So that's where they intersect. Perpendicular lines. Perpendicular lines are lines that are at right angles. A right angle is a 90-degree angle. So they're at right angles with each other. As you can see, sometimes it's has the 90 degrees. Other times it'll have a little square indicating that it is a 90-degree angle. But both of those indications would indicate that it is a perpendicular line. Horizontal lines. Horizontal lines, when they're used in drafting, horizontal lines are the straight lines that are parallel with the top and the bottom of the map or the drawing that you're working on. So an example is shown there. Vertical lines. Vertical lines are lines that are straight lines that are parallel to the sides of the drawing. So horizontal lines will run east and west if your map is oriented north at the top, and vertical lines will run north and south if your map is also oriented to the north. So on any particular drawing, horizontal lines are always parallel to each other. Vertical lines are always parallel to each other. And the relationship between horizontal and vertical lines is that horizontal lines are perpendicular to vertical lines. So all horizontal lines intersect at a 90-degree angle from vertical lines. And lines that are neither horizontal or vertical are referred to as oblique or inclined lines, just as a reference. So an angle, let's talk about angles. An angle basically are two intersecting lines, but it's the opening between straight lines that meet at an intersection point. Those lines are called the sides of the angle, and the point where they meet is called the vertex of the angle. You could see the drawing there in the map, or excuse me, you could see the drawing there in your manual. So angles can be measured, and angles can be measured similar to a circle. They have the same relation, but angles have a maximum of 360 degrees. If you go all the way around a circle, you have 360 degrees, and so we use that information to know at what angle a line is based on that. So, but more than just degrees, degrees can actually be broken down into smaller portions, so we can get a little bit more accurate measurement. They can be broken down into minutes. There's 60 minutes in each degree, and the minutes can be broken down further into seconds. There's 60 seconds in each minute. So just like time, there's 60 seconds in each minute, there's 60 minutes in each degree. So at any given measurement, you can figure out where that angle is in relation to the circle. So in cadastral mapping, we use degrees, minutes, and seconds, and we'll talk a little bit about those in further detail as we get into some of the other chapters. But as we measure those angles, we're just measuring those in relation to directions on a compass. So let's talk a little bit about triangles. Okay, there's a couple of different types of triangles, and there's actually 4 different basic types of triangles. And there's a brief description in your book about them. A right triangle has 2 sides of the triangle that are perpendicular to each other. Okay, so they have that 90-degree angle, and the right angle is always 1/4 of the circle. So it's always of a 360 degrees, and so it's always equal to 90 degrees. So that's a right triangle. An isosceles triangle. Okay, so an isosceles triangle, that's where 2 sides of the triangle have the same length. So any shape, but 2 of the sides are the same length, and because of that, isosceles triangles, you can usually recognize them pretty easily. Equilateral triangle, all 3 sides of the triangle have the same length, and therefore all the sides are equal. Okay. A scalene triangle is the 3 sides of the triangle all have different lengths, or each one has a different length. So those are the 4 basic types of triangles. Going back to angles, there's 3 different types of angles. We've talked about a right angle, that's at a 90-degree angle, but there's 2 other types of angles in addition to that. So any angle that's not a right angle is called an oblique angle, and there's actually 2 different types of oblique angles. So those that are less than 90 degrees, and those angles that are less than 90 degrees are considered acute angles, and those that are greater than the 90 degrees are called obtuse angles. So the angles in a triangle, man, these are all mixed up. Why do we go angle, triangle, angle, triangle? I don't know. I didn't write the book. Actually, I did write most of it. So let's move on. Altitude of, let's talk a little bit about altitude of a triangle. Okay, so we'll talk a little bit about altitude of a triangle later as we get into the the basic math portion, but an altitude is represented by a line perpendicular to the base, and is drawn up to the top of the triangle. So oftentimes the height of a triangle or altitude of a triangle, those are the same things. Different math problems will call altitude out of some of them. Other math problems will say the base and the height, or the base and the altitude. But the altitude and the height refer to the same thing. As you can see there, altitude or height are the same. So parallelograms. Parallelograms are four-sided shapes that have two sides that are parallel, and have two sides that are the same length. So if the sides of one pair are perpendicular to the other, it's a rectangle. If they're not perpendicular, then it's a parallelogram. But a rectangle is a common form. Parallelograms, the sides are at a different angle. So a trapezoid is similar to a parallelogram, with the exception that it has four sides and only two of them are parallel. The other two are not. They would intersect at some point if we extended them out. But those are some polygons, the parallelograms and the trapezoids. So let's talk a little bit about circles and elements of a circle. You should know the elements of a circle. They're used in descriptions quite frequently. So you should study some of the elements of the circle. You'll need to know those. But below are some of the principal terms used in connection with the circles. You can see the chord. Okay, so a chord is anything, is a portion of an arc or a portion of a circle, and it's the straight distance between them. The diameter is the length from one side of a circle all the way straight through the center to the other side. A radius is from the outside of the circle to the center. So a diameter is actually twice the length of the radius. The circumference is the entire distance around the outside of a circle, and the arc of a circle is a portion, just a portion of that circle. So those are some of the basic elements of a circle. Let's talk about some of the equipment that we're going to use. So in your manuals you've got pictures of these, but sometimes the pictures are hard to see, so I have a lot of these items with me. Some of these items I'm hoping you've seen before, but we're going to go through them, and if I have a copy of them, or if I have something similar, I'll pull that out and I'll show you. So drafting triangles. I actually have drafting triangles, but I didn't bring them with me today. But drafting triangles are exactly what they are. They're triangles. They're plastic, and usually one is in the shape of a 45-degree angle, and the other is a 30-60 angle. You can see there's a pretty good picture of them in your manual, and then both of them also have that 90-degree angle. Those are drafting triangles. An electric racer. Okay, I actually do have an electric racer. It's not plugged in, but when you push the button right here, this button right here, this rotates. Let's see if you can see that. The nice thing about the electric one is it just comes, and I'm just holding it along. I just basically trace the line and it's disappearing. It is flipping pieces of eraser all over and hitting me in the face. So you know, in the manual it says it shouldn't, electric eraser should not be used on that surface because it uses too much of the material. I've used them. You just have to be very careful because it will very easily remove that surface and won't allow you to draft on that. Some of the other things you can use is I like to use, I don't know if you can see these. This one right here is a magic rub eraser. This is the one I use. My staff likes to use the kind that are in the shape of a pencil, so it's just to peel away. Those seem to work fine. I prefer this one, just preference. But you can erase these. It takes the pencil off just fine, and you'd have to work really hard to get any of the material off. So, and these are cheaper than buying an electric eraser. So if you're going to go with something, something like this is pretty easy. As you're doing the erasing, there's what's called an eraser shield. Okay, and it's used to protect the lines around those that are being erased. So oftentimes you only have to change one line, but there's a lot of stuff around it, and so you can use an eraser shield. I don't know if you can see that. I'll put it over here, but it's just a thin sheet of metal. Okay, so the metal doesn't do anything, and so you can, if you had a line, you can erase it, and just it protects everything around it. So eraser shield here, thin piece of metal, and it's got different shapes to hopefully help you with whatever shape you are trying to erase. A straight line, different thicknesses, dots, circles, words, things like that. So that's an eraser shield. An engineering scale, okay, that's what next. I've got two different engineering scales here. I've got a really old one and a newer one. They're plastic. I've got some metal ones, but an engineering scale, you will need to know what an engineering scale is for the test. You will probably have to use one for the test, so make sure you understand what they are. So if you don't know what they are, an engineering scale, and I'm going to use the old one for an example. But as I turn this, you can see the color in here just represents a different side. So that one is blue, this one's red, and that one's white. But each one represents a different thing. So because it's in the shape of a triangle, okay, then it then gives us 6 sides to do it, because there's 2 on each side of the triangle. So this is an engineering scale. I'm going to read you exactly what it says in the book, because you're going to need to know that. But it's a tool for measuring distances and transferring measurements at a fixed ratio of length, and is divided into decimalized fractions of an inch. Okay, so it's all based off of an inch. But the cross section is like an equilateral triangle. I told you it has 3 equal sides. It has 6 edges, and the measurements. The scale is graduated in units of an inch, divided into 10, 20, 30, 40, 50, and 60. So if you have 1 inch equals 500 feet, you'd use the 1 inch, you'd use the 50 side, and then you can mark that distances. 1 inch equals 200, you'd use the 20, and that you just add a 0 as you go. So these are engineering scales. If you don't have one, you should have one. The next couple of pages talk about compasses. Compasses are used for a couple of different things. I've got a couple of sets of compasses. I have a simple set of compasses here that's there. This is actually the set that I got while I first started taking the cadastral mapping class, back when I was like you guys. It's fairly cheap. I don't use them as often as I thought I would, but it's nice to have. Basically, compasses are used to draw circles. So They come in all different sizes. You can see I have 2 different bow compasses here. Wow, don't poke yourself because they have sharp points too. So I have 2 different size bow compasses here. I have a medium size one and a small one. They both have an adjustable thing right here, so as you move that up and down, it opens it or closes it. This one's on the side, but it's still there. So those are both compasses. Excuse me, those are bow compasses. Another kind of compass. Oops. So with this kind, you've got also an armed compass. So some compasses, they if like my medium compass will go all the way out, and if you need a circle bigger than that, you can get an extension, and some of those you can get. My little compass set here has an extension you can add to it, so it's very similar. You add it out there, and it makes you it allows you to get a bigger circle. It's not set up like that, but you replace this arm with this one, and then put it, so you kind of put them together. So that's an extension to a compass. We have dividers. Now dividers are very similar to like a bow compass. Let's see if I can pull one out without poking myself. So a divider, very similar to that, but it doesn't. You just pull it out, but it's used to measure off distances. So as you can go to your scale. Where did my scale go? You can mark off a distance you want. Where can you see? On your scale, and then go on your map, and you can measure. You say, okay, well, each one of those is 100 feet or 200 feet or whatever your scale is. And so as you mark that off, you can spin it and measure how many things are within that. Oftentimes the sheriff's office or someone will come in and say, hey, I need a conditional use permit, or there's been a crime. I guess the sheriff doesn't come in for conditional use permit. They come in for crimes and things like that, but the public may need a conditional use permit, or the sheriff's office has a crime. They need to know if it's in a certain distance of a school or they need a conditional use permit or some sort of permit, and they say, I need to know all of the parcels within 500 feet. You can use that divider to measure it off, and I guess you could technically use a compass also to draw a circle around it, and it's kind of neat some of the stuff you can do to make sure you get all that information. Very useful tools. You can make a copy and draw them. Adjustable curves. I actually don't have any adjustable curves, but I have something different. Well, I've seen an adjustable curve. It was very fragile because it was very old and it broke, and so I just didn't want to bring it here. We do have I have a curve pattern. I don't know if you can see it. So you can trace the inside of each one, the outside, and so this is one scale and this is another scale, and so it helps you draw. If you have a specific curve you need to draw, you can use these. A flexible curve, I don't have one of those. Railroad curves. Railroad curves are just a set. They come in a set. They're strange curves, basically, but they're used to draw those circular arcs and radiuses that are greater than can be obtained with a compass. They're usually huge curves. Templates. There's all different types of templates. you've got this. So I just brought one, template's called all different shapes and different things, and so you can use it for different things. There's circle templates, lettering templates. There's all sorts of weird templates that you can get that can help you draw whatever your shapes you need to draw. This one's got some weird things on it, well used. A protractor. Okay, everyone should know what a protractor is. I should mention that as we talk about it. So some things you'll need for the homework are the engineering scales. Also protractors. Okay, a protractor. You'll need a protractor. Where'd my other protractor go? I don't know where it went. Okay, I just have a circle one. Protractor. You can see there's two different types of protractors as shown in the book, but it has a center point with a cross that marks exactly where your angle starts, and this one has 2 degrees. This one goes 360, and it's also marked 180 and 180, so it does it twice. So that's a circle compass. You can get these at any you can get them at Walmart, because these are used in elementary math. And I'll be honest, I don't actually use when I'm drafting my hand. I don't use a protractor. I use a land measure compass. Okay, so I don't know if you can see that. Okay, but the land measure compass, pretty good picture in your book. It has an adjustable arm. This is basically a protractor specifically designed to draw bearings on a map. So the difference between these two, the biggest difference is this one goes 90, so it has 180 degrees, from here all the way over to here, or it has 360 numbered all the way around here. This one only goes to 90, because your bearings never go more than 90 degrees, because it's also got north, south, east, and west on here, because if you're moving your compass there, you're always going northeast, northwest, southeast, or southwest, and so this is nice. It makes it really easy to mark out the bearings, and it's see-through, and there's some grids, and so I really like this. This is what I always use. I always have a couple extra on hand. In fact, I have another one right here in my book. That's much easier to see because it has the white background. So they're by Westcott. Simple. So you'll need either a protractor or a land measure compass. Land measure compass, you can get them on Amazon. But if we're gonna do these, the drafting by hand is much easier with one of these. This is what I recommend. But you can get along with a protractor, but you'll need one of those too. An irregular curve, also sometimes called a French curve. Okay, kind of a funny. They've got all sorts of weird curves on them. But the various parts of this and edges are different curves and radius that are used for drawing lines and irregular shapes. You can see that this one matches one of the ones here, but there's a couple of different kinds of irregular or French curves. Another thing that you will need is a drafting pencil. Okay, here's a drafting pencil. I wish I had a normal pencil. I don't have one with me, a mechanical pencil. But the biggest difference between a mechanical pencil and a drafting pencil is the tip. Okay, I don't know if you can see that, but the tip right here has a longer shaft. Okay, so or a longer sleeve that the tip is there where the lead comes out. It makes it easier so that as you're drawing along the edge of a ruler, it gives you a larger area to do that. So it just really helps with that. They come in a couple different sizes of lead: 3mm, 9mm, as well as your standard 7mm and 5mm. I prefer mine is a 7mm. Couple different reasons: because it's easier to find lead for it. If it's 5 or 7, I choose 7 because the lead is a little bit thicker, and because I use a softer lead, it's a darker. It shows up on the film, and so it breaks a little bit easier. It's a little bit more fragile, so I use a 7 to kind of help keep it from breaking and stuff. So that kind of leads us to our next one, is drafting lead. Okay, so drafting lead and kind of their relationships, and you should know the differences between these. This is because it's important to know what type of lead to get if you're drafting on what type of medium. So this lead that I have in here is actually a 2B. It's a little bit softer, but it's darker, and you can see with this it goes from 9B, which is very soft. A 9B would almost be really hard to write with. Most of that's used for drawing and things like that. And the harder your lead is, the lighter it is. So you can kind of see with these pictures down here what you can see, but it goes up to a 9H. So an easy way to remember that: H is harder. Okay. B is softer. HB, which is right in the middle. So HB is the same as a number 2 pencil. The standard ones you use to take the Scantron tests when you were in elementary school and in college, those are a number 2 pencil. So that's right in the middle is where your standard number 2 pencil is. So you can see that the 2B that I use is a little bit softer and darker. But it's nice. It shows up on paper really well, and it also shows up on my drafting film pretty easily. And so I like that. It shows up better when you scan the Mylars in, and so it makes it nice with the technology that we have. Ink pens. Okay, I used to have some ink pens, and they all dried up because I just don't use them as much as I used to. But ink pens come in a variety of different colors, different widths, similar to a pencil, how they're standard widths. They also have different widths used. The interesting thing about line widths is that you can show different things based on the line width. You know, for us, we use the outside border of a subdivision is always thicker than the inside lots. It helps represent what the boundaries are versus the individual lots. So you can use things such as line widths when you get pens and pencils to represent some of those things. Lettering. Talk a little bit about lettering. Lettering, oftentimes they have different strokes that they have, and a single stroke lettering does not mean that an entire letter is formed with a single stroke. Okay, it's just called single stroke. But it basically means that each one of the lines is made with one stroke. So there could be multiple lines, as you can see in the little picture. A T is actually 2 strokes, but each stroke each line is 1 stroke. They have what's called an Ames lettering guide. You can see one here. I don't know if you can see that. I've got one in a package here. Wow, you really can't see that. Let's see if we can put it on a white paper. There we go. There's a bunch of little holes. You rotate this circle thing and line up the holes with the holes along the side, similar to the picture you can see here. And based on the angle of that, you can set it to different gauges. You line your holes up and you draw lines across, and that creates how big of a gap between the lines, and so at what point, what size font do you want to use. So that's when you're hand lettering, that's a way to determine the size of font. So it's common among cadastral mappers to use those all the time. You'll see the faint little lines when looking at them. To do that, there's also lettering devices. You can see a couple of different lettering devices here in your manual. The Leroy lettering set, the pen and pencil. So we actually have one of those in my office, and they have all these ruler looking things, and they just have the alphabet on them, and with, you just basically you trace with the stick, and it actually draws right above it that size. So whatever size font you had on the stick, that's what you drew. Later they came out with an electronic lettering device that you have. You can see the one here in your manual talks about that. They were kind of interesting. You type it in, then you push print, and instead of like a label maker where it prints out the label, it would actually draw it with the pen, with the pens that we talked about earlier. Oh, T-square. It is here. It's in the back. Since it's mentioned, this is a T-square. You're able to use that. Oops. So you can measure your T-square, and you use the T portion, the top portion, and then you've got a ruler that goes perpendicular to your paper. So this is a T-square. Drafting media. There's a couple of different types of drafting media. The most common drafting media in the state of Utah is done on a stable database. That's the polyester type film. You can see a picture of that. It's just a thin sheet of basically see-through plastic with that layer on it. Some advantages are you can draw on it. It's erasable. It doesn't rip or tear like regular paper can, but it can also be microfilm reproduced, and the storage life is much longer. You can also draft on paper, different types of stuff. Something else that I recommend that you pick up from your homework is some graph paper. It's really nice to have the graph paper that you can use. This pad of graph paper is pretty cheap. You can get it online, or you can get it at Walmart or any store like that. It makes it drafting much easier. And when we talk in some of the drafting examples that I'll show you later, I use the graph paper because it makes it easy to do to draft on. You can see your rotations and you can see your angles based on what you're supposed to do. Also, it's nice because as you're drafting, if you have to rotate something or things like that, you can draw it on the graph paper, and if you're not sure before drafting directly onto the Mylar, you can draft it onto the graph paper to make sure that you're at the right scale and it fits like it's supposed to, and then you can draft it or trace it onto the Mylar or the film. So that's really that's really all the stuff we have for this chapter. Like I said, most of it's tools. So look at the homework. That's your homework, is to actually get the supplies you need in order for the hand drafting course. We need to make sure you get those. And so if you don't have them, check your supplies. If you don't have them, order them. If you have trouble finding something, contact me. I can help you, or I can provide you with links where to find them in Amazon. But again, I'm going to go over exactly what you need. You need an engineering scale for the drafting. You're going to need a compass, okay, or a protractor. I like the land measure compass because they're super cheap. It's see-through, and it really helps with your bearings doing it with this, but it's possible with just a standard. I actually did my original cadastral mapping class, I believe, with this very protractor. But since then, I found one of these. It was all old and yellowed, but you can still buy them. You need a drafting pencil, and with some lead in it. For our example, we're only going to draft on paper, but I recommend you getting some graph paper. Not necessary, because you can draft on normal paper, but graph paper will make it much easier, and then just an eraser of some sort. But those are the things that you will definitely need for that. There's a list of other recommended things that could make it easier for you as you're drafting some of those supplies, but make sure you get those supplies that are necessary for those chapters. So get them now, and you'll have plenty of time, and make sure that if you need to order them, they can arrive on time or whatever. So thanks for taking part 2 and talking about the history and the basics of drafting. Our next chapter, we're going to talk a little bit about surveying.